Okay, everybody, let's get started. Welcome back. It's the dark and somewhat dreary fall day. You can kind of really feel fall starting to kick in after this little bit of Indian summer that we've been having. So this lesson and kind of this week is going to be focused on some, I don't know if we call them advanced, but I think these are concepts a little bit different than particularly some of you that are familiar with Java and have seen some of it in AP or in high school or in the past may not have seen some of these concepts. So I hope that this is valuable for you. And for those of you that were new when you came in, this is going to represent kind of a continuation of the stuff that we've been talking about. So, one of Java's very distinctive features is this class hierarchy model. However, it actually has a lot of limitations to it. And one of, I think, the more, any language, comes out, evolves over time, sometimes in response to features that are added by other languages, and sometimes the things that, people added to the language early on don't look like such a great idea later on, like, for example, public instance variables, which we've talked about, are pretty much by convention just not used. And I think, the inheritance model in Java, while it is, can be a good fit for certain things, the inflexibility of it is sort of a problem. And so what we're going to talk about today is this idea of interfaces, which is not just a Java language concept, but is also a much broader idea in computer science, sort of like references. So this is in some ways akin to what we did last week, where we're not only looking at something that has a specific realization in the Java programming language, but it's just this bigger idea. And I think interfaces in many ways are even more powerful in the sense that you see interfaces all over the place. And understanding what happens in interfaces and being able to communicate across them and understand how those communication patterns work is something that is an ability that you will carry out of your work with Java, right? Past this class, out into other classes, out into the world as you build real things and go forward. So, okay, so there's two kind of things that we're unpacking today. The first is, what is an interface? And an interface is a place where two things meet. I mean, I think that's sort of like even, maybe we can look up the actual dictionary definition, right? So interface definition, let's see here. It says, a point where two systems, subjects, organizations, etc. meet and interact. And so, in broader use, this term has this connotation of a place where two things come together. You can think of, we're going to focus on applications in computing when we talk about this term, but you can think about interfaces as being something that you experience all the time in the real world. So I had to be careful not to use this. I think before we talked about this example of like when you go to a restaurant, right? Well, think about if you go to like a fast food restaurant. There's a counter, right? That you walk up to place your order. That counter represents the interface between you and the restaurant, between you and the kitchen. That's the place where these two things come together. And just like our computer interfaces, there are conventions and agreements about what happens at that interface, right? And like we talked about in the past, as long as you communicate your order effectively, maybe some of you have realized that, like, I'd really love to go out to eat again someday. So if you communicate your order effectively across that interface, what happens in the kitchen is not, important, except to the degree that like it's sanitary and stuff like that. But the idea is, you go up, you say what you want, and then there's some process by which they notify you when things are ready, and that's also part of the interface, right? Like, how do you know what's your food, right? Like, you place the order, something happens back in the kitchen that you don't always have any idea what it is, and depending on the quality of the restaurant that you go to, it could be dodgy or it could be just some guy cooking something, right? And then there's food that's brought out, right? So that's an interface. That's a real world example of an interface that really has nothing to do with computers. In computers, we see interfaces all over the place. Not only internally between two pieces of code, right, which is one place where you see an interface. You see interfaces between two programs that run on different machines, different computers, right? Interfaces that are sort of occur over the internet, where the interaction happens over some sort of computer network, right? That's an example of an interface. You see interfaces between two different parts of a computer system, meaning like a peripheral and your main computer, right? You plug something in via one of the ports. That port is an interface. And like other interfaces, there are agreements and conventions and documentation and rules about what happens there, right? Like, you know, the thing that you plug in to the USB 3 port or whatever has to conform to that interface in a variety of different ways, right? I mean, first of all, the plug has to be the right size. If the plug doesn't fit, then you're not going to get very far. And then the device that's at the other end of the connection has to communicate with your host machine, obeying the USB 3 protocol, which I don't have any idea what that is, right? But the idea is there are rules, right? There is a guide. You could find the specification for this somewhere online if you were starting up your own device maker. And if you followed that carefully, you would be able to build a piece of hardware that would now be able to connect to any device that has USB 3. And actually, on some level, that ubiquity is something that we're going to come back to over the next couple of days, because one of the things that's really cool about interfaces is by providing them or by using them, you gain all this generality, because, you know, and we'll come back in a few days and we're going to, you know, really drill down kind of the user versus the provider of an interface. But in general, if we agree on what happens across an interface, this also allows two completely different groups of people or teams or whatever to work completely independently from each other. So, you know, again, let's go back to USB as an example of an interface. So imagine that we didn't have that sort of agreement. Imagine that every single computer that came out, every single laptop, had a different shaped hole that you plug things into, right? With a different shaped plug. And internally, it communicated with the device on the end of that in a different way. Imagine what a nightmare that would be. You know, and so now if you're making like some sort of doohickey, right? Like a microphone, for example, like, or a webcam or something. Now, if you want to work with the MacBook Pro, you've got to go talk to Apple and figure out how to get that to work. And then if you want to work with a ThinkPad, you have to talk to IBM and figure out how to get that to work. It's like, that would be a mess, right? It would be terrible. That it would really limit the ability of, you know, these two groups to work independently from each other. So right now, the company that makes the laptop, the company that makes the peripheral, are two separate companies. They don't need to be in direct communication with each other at all. They don't have to know anything about the other person's existence. A lot of times, you know, a laptop comes out, and then 5 years later, a peripheral comes out, and I can connect that peripheral to my laptop, despite the fact that when the laptop was designed and produced, no one even knew that that peripheral existed. And the reason for this is this agreement, right? It's this interface that everybody has decided to sign on to, right? And again, there's actually a lot to be gained from both sides in agreeing to this. So if you make a laptop, by opting in to USB or USB 3 or whatever, you now automatically gain the ability to interoperate with all these peripherals. So that's good. Now, if you're making peripherals and you conform to this, which of course everybody does, you now automatically out of the box can now be connected to all sorts of different computers. And so through this agreement, through this common interface that everybody has agreed to, it just really magnifies the effect of all the work that these individual groups are doing, right? And it requires no coordination, right? Once we agree on the interface, the laptop makers go about their business, the peripheral makers go about their business. Nobody has to communicate with each other directly. You don't have to call up IBM and be like, hey, can you tell me about the plug, you know, shape on your new laptop that's coming out, because I want to make sure that we're ready for it. It's like, no, it's going to be USB 3. You know what the plug shape is. It's in the documentation, right? So anyway, maybe I'm somewhat of a long-winded example, but this is, you know, the power of agreeing on places where things come together, right? So, you know, all of the internal hardware of the MacBook is irrelevant to the microphone maker. All the internal hardware of the microphone is irrelevant to the MacBook maker. The only thing they agree on, and, you know, I'm not saying that the USB specification is simple. It's probably fairly complicated. but it's way simpler than all of the complex electronics that have to be implemented on both sides of it, right? So the interface is typically this, it's a smaller place, right? Think about where two things come together, right? That interface is smaller than all of the mass on one side and all of the mass on the other side, right? But as long as we agree on that, what happens across that interface, it really, improves. And this is why systems work on ensembles, because we have these type of conventions. It's why the internet works. We'll talk about that more later in the class. So anyway, interfaces, are everywhere in computer science. They're incredibly important. Understanding how they work is really useful. Okay, so, and by the way, feel free to stop me with questions. I'll probably talk a little bit more than usual today because we're introducing some new stuff, but I'd love to take questions about this. And you guys always have really excellent questions. So, all right, so now, again, one thing I want to be clear about, and I'll keep coming back and hammering this over the next couple of lessons, is that interfaces are an idea. There is an interface keyword in Java, and you can see I'm using it as part of this example that is right here on the top of the, I don't need public here, right here on top of the slide that has a compilation error that I've encouraged you to try to fix. So there is an interface keyword in Java. Some languages have an interface keyword. I think Go has an interface keyword. I don't know. There's a bunch of languages that have built into the language a notion of what an interface is, and they're all pretty similar. There are other languages that don't have this notion at all, but it doesn't matter. They all use the idea of an interface. Whether or not the language has a specific meaning for it, or whether it's just done through convention. And one of the things I point out as part of the lesson is that even if your class doesn't declare that it implements an interface, it still has an interface. The interface is all the public methods that someone can call on it, right? So if you think about it, like when, oh, hi. Oh, look who's here. Are you going to help? Okay, you can sleep here if you want. She's here to help. Cats like interfaces. So, all of those public methods that you can call on the class, that's the interface. Now, what we're going to talk about today is how by implementing an interface, you agree to a specific set of rules that cause your class to now be similar to other classes in ways that can be useful. But even if you don't implement an interface, the interface to your class, if you give me an instance of your class, the question is like, where can I interact with? What's the surface with which that I can do things with it, right? If it has a public method, then that public method is part of the interface because I can call it and it'll do stuff. If it's got a public constructor, hey, that's my trackpad. If it's got a public constructor, then same thing. The constructor is part of the interface, so I can create instances of that, right? So every single class in Java has an interface, even if you don't declare an interface and implement it specifically. The interface is what I can do with that instance of the class. If you program in Python, right, and you create a Python object, it has an interface. Same thing. It's the methods that you expect people to call on that instance of that class, right? If you program in C++, same thing. You create a class. It has an interface. I think C++ actually has a notion of interface because C++ has every feature ever invented. But anyway, so just the fact that Java has interfaces and has a specific meaning for them does not, take away from this broader idea of what an interface is and how it's useful. But let's actually look at what Java means by an interface. So in Java, I can declare an interface, and so again, we'll puzzle through this together. This is if we look at this piece of code, we see some things here that look familiar. I see a class declaration, I see a method declaration, and then I see some stuff that looks weird. So when we see weird things, we squint at them, we try to identify things about them that look familiar, and we kind of point out where some of the differences are and try to understand things that way. So the first thing I see here that's weird is this keyword. I haven't seen this before. Interface. Check that off on your Java keyword bingo card. We're getting close. Someone's going to have bingo soon. This is another keyword in the Java programming language, and this starts the declaration of an interface. Now, the rest of this looks kind of similar to a class declaration that we've seen before. I've got a capitalized name, which is my convention for classes in Java, and then I have a body. And now in here, what I have are things that look a little weird. So on some level, this looks like a method. It starts off looking like a method declaration, right? I've got a return type, I've got a name, I've got a parameter list, but then suddenly, boom, I'm done. There's no implementation here. I don't have anything inside curly brackets. There's no body to the method. And that's what an interface is. An interface says, in order to implement this interface, you have to implement methods with these signatures. So in this case, if I want to implement math and become a class that implements the math interface, it defines two methods that I then have to implement. The first method is called add, takes two numbers and returns an int, two ints and returns an int. The second one is called subtract, takes two ints and returns an int. Okay, so on some level, we see the interface keyword instead of class. Inside the body of an interface declaration, I see sort of like empty method declarations without a signature. And that's important, right? Because, when we used classes before, when we declared a class method, we had to provide an implementation. The idea of an interface is, no. We're just agreeing on what methods can be called on something that implements math. We're not saying how they should work. Now, usually there's documentation about that, but we'll get there. Okay, so now I've got this class mathematical, and most of this class declaration I've seen before, public class mathematical, but now I've got this new bit here. Interesting. Implements math. This is how I tell the Java compiler that my class is going to implement an interface. Public class whatever, extends, that's how I set up an extension. I can set myself to inherit from another class. And then another part of the class declaration is this implements clause, where I get to determine what interfaces, if any, the class is going to implement. Now, we've never used this before, and obviously it's possible for a class not to implement any interfaces. Now, again, every class that has public methods has an interface. To implement an interface in Java means to enter into an agreement to provide the methods that the interface declares. And so when we try to run this code, the compiler error that we're getting is because of the fact that the interface math, so basically the interface math says in order to implement this interface, you need to provide two methods. One called add, takes two ints, returns an int. Another called subtract, takes two ints and returns an int. My class has only implemented add, and we have never implemented subtract. So let's implement subtract here. So I'm going to add a method called subtract. Subtract. Okay, and now we're good. Now the compiler's happy. One thing I want to point out here. This subtract method's wrong. It's not actually doing subtraction. When I implement an interface, usually the interface has lots and lots of documentation about what I'm supposed to do in order to implement it. But that doesn't mean that I did it right. The compiler has no way of knowing this, right? We'll come back when we talk about comparable in a minute. Typically, so this is not a particularly great example of an interface, because typically where we use interfaces is when we need to provide, where there's a bunch of classes that want to provide sort of a common piece of functionality, but the way that it's implemented for each class is different. When we talk about mathematical operators like add and subtract, there's only one way to implement them properly. And so there's no reason to create this interface because, there's only one way to implement add. And there's only one way to implement subtract. So there's no reason that a class would need to provide its own implementation for these. And of course, obviously, I would just use plus and minus, the built-in Java operators for doing this. But the idea here was just to showcase the fact that until I fulfill the contract that the interface specifies. So the interface says, in order to implement me, you got to do these two things. And I had only done one of them, and that was causing the compiler. So let's look at a real-world definition of an interface. I'm going to look up comparable Java 14. So this is an interface that you guys are going to work with a couple of times, and the reason for this is that it's really useful. And so this is Java. So every time we take a step forward, we're still seeing things as like, oh, what's going on here? So this right here, just ignore it for now. We'll get there. We're going to talk later about Java generics and type parameters, and some of that will make sense to you by the time we're done. But for now, let's just ignore it. Let's look down here at the definition of this, and I go through this in the lesson too, so you guys can watch it. So the idea is, so this is a built-in interface in Java. This interface is, if you look at it, it's in java.lang. So actually, I don't even need to import it because it's already there for me. So I can just automatically implement this interface without importing anything. Remember, everything in java.lang automatically gets imported. It's almost like your program starts with import java.lang.start. So I get everything from java.lang. That's where string is, math, a bunch of useful stuff. So comparable is useful enough that it's actually in the java.lang package, meaning that I get it out of the box. And if you see, so this says all known implementing classes, and there's a bunch of things in here that implement comparable, including string, something called a string buffer, some other classes that we've seen. So let's see, these are alphabetical order. Date, both dates, day of week, you know, and this is just the stuff that Java knows about, sort of part of the Java standard library. There are probably like thousands of hundreds of thousands of different classes that implement this interface. And so this is an example of an interface that embodies a property of a class. And this is something that you can opt into by implementing. But let's talk about what it actually allows you to do. So the question is, you know, what sort of point of contact is this establishing and why? Comparable, if you implement comparable or you use comparable, it allows you to compare two instances of a class to each other. In terms of determining which one comes first and which one comes second, or whether or not they're kind of at the same place. And so we saw that string actually already implements this. And so let's mess around with it a little bit with string. So I'm just going to go back up here. I'll grab this playground. Let's use string. So we'll say, first of all, we can use instance of to test whether or not a class implements an interface, just like we used it to test whether or not a class inherits from a particular superclass. So I can do system.out.println. Well, let's do string s is equal to new. I'll just use a literal here, s instance of comparable, and it's true. The reason, so comparable is not a superclass of string. String actually inherits from object, but string implements the comparable interface. And so if we go and we look up string here now, we'll see that all implemented interfaces, comparables, and again, we'll come back. This thing inside the brackets, just pretend it's not there, but it implements comparable. Okay? So what does that mean? In order to implement comparable, it has to provide what method? Well, let's go back and look at the comparable interface again. So the comparable interface requires that you provide one method. So this interface, if we looked at it, it would basically look like interface comparable and compare to some other object. Hi. You're being disruptive today. You smell a little bad too. I know. All right. A little cat friend here who's trying to help. What? Okay. Love you. So we got to implement this one method. So if string already implements comparable, then we know that it provides this method called compare to. Let's just mess with it a little bit and get a sense of how it works, okay? So let's do s.compare_to, and I'm going to pass it another string, and since she's on my mind right now, and I'm going to print it. So obviously I can call this method. What I want to do is I want to print it -4. And that's interesting, okay? What about if I compare it to like something like choo-choo? Choo-choo's asleep, but okay. And so let's look at what the comparable, so it says, returns a negative integer, 0, or I hate this description method, it's so confusing. Returns a negative integer, 0, or a positive integer, as this object is less than, equal to, or greater than the specified object. I could not, like if I wrote this on a quiz, you guys would kill me. Like, it's so unclear, right? Just give us a little table. Okay, so now there's 2 points of confusion here, right? What is the specified object? That's the object that's passed. Okay, and then negative, 0, or positive as this object is less than. So if it's negative, it's less than, okay? So let's try this again. We'll try ziz. I get a negative value. So that means that test according to this compare to that's built into string. I didn't implement this, right? We're just using what string already provides. Test is less than ziz. Okay, that's interesting. What about choo-choo? Okay, test is greater than choo-choo because it returns a positive number. What about if we compare it to itself? 0, okay? So that's equal to. Let's try some other values. Let's try this, okay? Let's try that, okay? So that means test is less than this, right? Let's try capital. That means it's greater than, is that right? Positive integer, yeah, it's greater than. And so what we're noticing here, let's try AAA, right? Let's try ZYZ. Okay. So what we're noticing here is the ordering that Java is establishing with these strings. And we can see this order in action actually also if we sort. So let's actually try that. This is going to give us a sense of how things are working. So let's try string. Strings is equal to, and then we'll use, it's going to be mad, test A, Z, A, Z. I'll just use a few sort of boundary characters here. And then I'll do, and we're going to use our arrays class because it's super useful for printing stuff. So first I'm going to sort it, arrays.sort strings. So that sorts the array without returning a new array. It does what's called an in-place sort. So it modifies the existing array. And now I'll print it. And I'm going to use this arrays.toString method and pass it strings. Okay, and so what we can see here is the ordering that's established. And so what we're noticing here is that the capitals go first, all the capitals, A through Z, and then we go to lowercase, and it's an alphabetical order. Let's put some like numbers in here and see where they end up. Okay, 0 looks like it ends up at the beginning. What about 9? Okay, so it looks like it's all the numbers, all the capitals, you know, A, and then Z. And actually, if we really wanted to figure out exactly how this worked, what we would do is we would actually go to string, and we would look up its compare to method. And it says lexicographically, let's see here, I don't know why the capitals go first. I guess that's how it works. Okay, so numbers first, capitals in dictionary order, lowercase in dictionary order. So that's the. Now, you might ask, well, why can I sort strings in the first place? The reason that you can sort strings is because they implement this compare to method. The thing, any array that I pass to arrays.sort has to implement compare to. And we'll talk about this a little bit more tomorrow, but this is one of the cool things that you get when you implement an interface, is that suddenly this other piece of code that you don't know anything about, when you implement a comparable, arrays.sort can sort instances of your class. All right, so let me take a talking break for a minute. We'll talk about if people have any questions about this concept. Before we go on, I'll take a few minutes, pet the cat, and then we can resume with some questions, or I think we've covered most of what I wanted to show today, which is introduce the keyword, give some examples of how you can implement an interface that you declare yourself, but then really kind of get into how to use an existing interface, right? So when I know that something implements comparable, what can I do with those things? And we give you an example of doing that, and then we ask you to generalize that a little bit on today's homework problem, which hopefully people will find fun. Are Java interfaces distinct from APIs? No. Like APIs are interfaces. It's a great question, right? Application programmer interfaces. The difference here is there's not really a difference, right? The qualifiers, right? API, right? Application programmer interface, right? So how is that different than just an interface? An API is designed for someone else to use, right? So whenever you build a piece of software, there's always interfaces internally, right? Between different parts of the program that you wrote. The API sometimes refers to the interface that you expect other people to use. So, I can think up some examples sort of from things that I've built, right? So the playground backend, right? Internally, it has all of these interfaces between, different parts, but the API is the part that you guys actually use when you compile your code, right? You send it some code, it does its work, it sends you back a result, right? So internally, it's got all these interfaces between different parts, but externally, the API is the part of it that's facing, and again, people don't typically say users, because users don't typically use APIs, application programmers, right? Somebody who's building something on top of your system. So another example, right? So let's look at, I don't know why this came to mind, right? So here's an example. This is a tool called Square. And again, I have no idea why this came to mind. Maybe I've been seeing too many of their ads on TV or something like that. Anyway, I don't use Square or have any promotional licensing agreement with Square. Square, as far as I understand, is a tool that's that's designed to help you take payments. And the idea is that Square provides an API for developers. Okay, no, I'm not going to sign up. Let's see if I can find the docs. Okay, here we go. Will it just take me to the docs? Yeah, and so think about it this way. Square, if you went to work in Square, you'd be writing code, okay? I have no idea how many tens, thousands, hundreds of thousands, millions of lines of code Square maintains internally. And internally, there's probably many different parts of Square's system that have to communicate with each other. They probably have lots of internal interfaces between different components that might be deployed on different machines, or even if they're deployed on the same machine, just built by two different teams, right? Let me come back to that, because that's one of the things that's really cool about interfaces. But if you were a developer and you wanted, let's say you were building an app and you wanted it to use Square to take payments, Square has an API, an application programmer interface that's designed for you to use. And so let's see here. So if I click on this, so it says integrate. So you can integrate with Square card readers. Let's see, integrate with digital wallets. They provide software that has an interface for you to use. So you could build stuff on top of this. So that's an example of an API. So, the real only difference behind them is that an API tends to be something that's more public-facing. The public is usually not like users, right? Because users typically don't write code. These are developers, an application programmer, right? Someone who's going to build an app. So, for example, somebody could, use our Playground backend to build a different type of system, right? And in fact, the homework grader that we built actually is built on top of our Playground backend. So that's one example of that. That's us building on top of our own stuff. But somebody else could take that API and they could, let's say they wanted to write an app where you experimented with Java code and ran it on the phone, they could build on top of it, right? Because it has an API that other people can use. So an API is an interface. Yeah, absolutely. And APIs are particularly important interfaces because they are this interface between you and the outside world, right? And so typically around APIs, you see much, much more documentation, right? So internally, and actually, since you got me started on this, there are some really fascinating questions that this raises. So for years and years, there were these ongoing sort of browser wars, and historically, one of the things that Microsoft got itself into trouble with a couple of times was people claiming that it was the people that built Internet Explorer had an unfair advantage compared with competitor browsers. And let's think about what that means. So Windows itself, if you were going to build an app on Windows, you are now going to be dealing with the Windows API. I've never done any Windows programming, so I have no idea how this works. But at a high level, the Windows API provides functions for doing things like opening a window, right? That's what you're doing, right? So it's okay, I open a window. How do I make the window look? How do I get the menus to have certain content? Whatever. So there's this whole set of functions, and it's really not that different than a Java interface, right? In the sense it's a set of methods that you can call that'll call Windows to do things like open another window and position it somewhere or whatever, right? And people build on top of this. So if you built a web browser and you were trying to get it to run on Windows, you had to build it on top of the Windows API. Okay? Now, the API, Windows is not open source. And so the API is all the information that an external developer would have about how Windows works. Now, again, I'm not a Windows programmer, so other people can probably tell the story better than I can. But my understanding was, and this is, I think, still true, Windows is a very old sort of operating system, and it's gone through many changes over the years. And so in many cases, there are more than one way of doing the same thing. So I might have so ideally you would have let's say I wanted to, I don't know, connect to a network or something like that. Ideally there'd be one function that would do this. But in reality, there might be 8 functions that do something similar that you can kind of get to work. And some of that might be because one got added in a previous version of Windows, and then you can never get rid of it because as soon as you have stuff that works in a previous version of Windows, it can never go away because there's some old game that somebody built somewhere that's going to die if you get rid of it. And there's 80 people that still play that game, but they will phone bank you to death if you ever try to get rid of that feature. So it's very, very difficult to get rid of stuff when you start building something that's really widely used. So that's something to keep in mind. Anyway, so there might be other versions of a function that did similar things that were added over time. So now imagine you've got 8 ways to do the same thing. How do you know which is the best? Maybe one of them is faster. Maybe one of them is less likely to cause a problem. Maybe one of them has some extra features that you might want to use. Well, if you're Netscape, you have no idea. You have no way of knowing, right? Because you can't actually read the code, which would be one way to find out. And you also have no internal contact with people at Microsoft. Now, if you're working on Internet Explorer, you can pick up the phone. You can call your buddy over in the next building and say, hey, Sheila, what version of, there are 8 ways to do this. You're one of the people that maintains this part of Windows. Which one doesn't suck the most, right? Which one is the one that you would recommend, right? Or can you give me a little bit more insider information about this? And so there was this concern. Now, Internet, it's so funny, right? Because on some level, I do think Microsoft had a huge advantage with Internet Explorer, and they still somehow managed to blow it. But that was the concern, right? The concern was that Internet Explorer had an unfair advantage because it could see past the API. It didn't just have to deal with the API. It could also talk to the people who built the code underneath the API. And sometimes, again, there's stuff that's not documented, or there's things about the API that people don't know, or maybe they're about to, make one of the functions not work anymore or something. So anyway, so this is, an interesting example of kind of where that goes. And so one of the proposals, and again, the fact that Internet Explorer someone will probably write a book someday about how Microsoft managed to squander the advantage it had on what turned out to be a pretty terrible browser. But the idea is that when people were proposing solutions, one of the things that they argued was that we should split Microsoft up into smaller companies. So that way, the people that build the browser now work at a different company than the people that build the operating system. And they should have the same access that someone at a third-party company would, right? So they should have the same access as the people at Google or the people at Mozilla or any other group that's trying to build their own browser. Now, again, these ideas really never came to fruition, and Microsoft didn't take advantage of that to build a really great browser. So, here we are today, where Microsoft's now building its newer browsers on top of browser rendering engines that were developed by other companies, which is interesting. Anyway, there's a lot of web designers out there that will be completely thrilled if and when Internet Explorer finally goes away, because Internet Explorer causes a lot of problems for a lot of people. Anyway, you guys like tangents, so there we go. Other questions? Actually, there's this fantastic story. I'll have to find it. I found this on Hacker News maybe 2, 3, 4 months ago. It's probably longer than that. I'll have to try to find it and send it out to I think I sent it out to the forum last semester. It was so funny. It's basically the story about how this developer at I think at Google basically claims that they killed off one particular version of Internet Explorer just accidentally, right? Because particularly older versions of Internet Explorer, so again, I'm in full-on tangent mode now, that's fine. Older versions of Internet Explorer had these problems, and the problems were that they didn't work properly. Like they would work most of the time, but one of the things that a browser does, and we'll talk about this more later in the class, is that it's supposed to take this code, essentially written in something called HTML, and render it so that it looks like what you see on the screen. And there are all these rules, and it's complicated, right? And there are a lot of rules about how things are positioned on the screen. So like, where should stuff be, right? So, for example, this has actually been bothering me recently. So this checkbox that you can see right here that hides some of the elements that aren't visible to students that I usually turn on when I'm doing one of these walkthroughs, this is like too far to the right, right? This should really line up more with this column. And so at some point, I'll get irritated enough about this that I'll go and bump it over to the left a little bit. And doing that essentially involves adding instructions to this page that cause the browser to position that element a little bit farther to the left. So when you take a browser and you load a web page, what it's receiving is actually a whole bunch of instructions about how things are supposed to look and where it's supposed to go. The problem with, one of the many problems with Internet Explorer is that it didn't follow those instructions properly. It would put things in wrong places. And sometimes there were just like small mistakes, right? But when you're when you're designing stuff and you're trying to get it to work on the internet, this type of stuff drives you bananas. Because it's like, let's say you use Firefox and you spend a lot of time getting things to look nice on Firefox, and you publish your website, and then someone, your friend who's using Internet Explorer, and obviously you're friends with them, because if you weren't friends, you'd be like, stop using that terrible browser. They load up the page and like everything's off, right? And again, web designers get fiddly about this stuff. They want things to look right? They spend a lot of time getting stuff positioned properly, and suddenly everything's like twisted a little bit or scooted over a little bit. And so people came up with all these terrible ways to work around these problems. Some of the problems, so that's actually really funny, because other people built their sites using Internet Explorer, right? And early versions of Internet Explorer had things where they were literally bugs, like they weren't interpreting the specification properly. And so when later versions of Internet Explorer came out and fixed the bugs, people who had built pages using earlier versions of Internet Explorer were angry because their pages didn't look right anymore. So again, they spent all this time optimizing how it looked on this other browser that had problems, and then now you've changed things and their page looks funny. And so I don't know if this is still true, but there were at least several versions of Internet Explorer where you could turn on, and I kid you not, this was a feature in the browser, you could turn on something called Quirks Mode. What Quirks Mode did is it basically caused Internet Explorer to render the page incorrectly, but in ways that were in line with the old incorrect ways that it had done things in the form. It's basically allowed you to re-enable bugs that they had fixed in the Internet Explorer rendering engine. So it was like, no, I need that bug. I've already built my page on top of it. If you make it go away, things don't look right anymore. So please give me that bug back. I don't know if this is still the case, but this is something that went on for a long time. But anyway, there's this great article about how someone claims that they had accidentally, somewhat accidentally, but basically managed to kill off a particular version of Internet Explorer, which is a pretty good story. People use Internet Explorer, right? I mean, I wouldn't, back in the day too, I mean, Internet Explorer now, is, I think, kind of seems like it's kind of headed for oblivion. I mean, even Microsoft is pushing other browsers, right? So, when your own company starts to like try to get people to use something else, it's like, I don't know, it would be interesting. I'm not sure how it would feel to work on Internet Explorer right now. I'm sure there are human beings, and I'm sure there are very nice people, probably some excellent programmers, who are still working on Internet Explorer, but I don't know how they feel about that job, given that their company is now, again, pushing it into the browser. But keep in mind, for a long time, when you got a computer, Internet Explorer was like sitting right there, waiting for you to use. And a lot of people use Internet Explorer, and a lot of people explored the internet using Internet Explorer. And so again, I mean, even something that's not perfect is is still, it probably opened up a lot of really interesting ideas for people. But, now we're talking 20 years ago, and that was, that was before. Now, I think a lot of people, I'm not sure this is actually true. It's interesting. I mean, there are some people like me who, the first thing that they do when they install a new machine is they put some other browser on. I don't use Safari either. I mean, it's, but yeah, no, I mean, there were, Internet Explorer had its day. But it was just, I don't know, the Quirks Mode stuff is really funny. And it's just, and going back to our discussion of interfaces, that's another example of kind of an interface. It's not a very thin interface. It's a really, really complex interface, but it's still a place where you need a lot of agreement, and it shows you how difficult that agreement can be, right? I mean, a lot of times, like, if you plug in a device to your computer and it doesn't work right away, like for example, every time I hook up my external monitor to my laptop, it probably takes like 20 seconds to turn on. And the problem is at the interface, right? Like there's some communication that's going on between the laptop and the display. This is not an Apple display. If it was, I'm sure it would come on right away. But there's some communication there that's just like not quite optimal. And so I can't fix it, but I have, at least I have some idea what's going on. But all right, any last minute questions before we call it quits for the day? So tomorrow we'll do more with interfaces. We're going to talk about implementing them in our own classes. We'll continue on with Comparable, because I think Comparable is a great place to get started. It's simple. It's easy to understand, but it's also one of the things that, again, like, is just super cool, because there's all this code that's part of Java already that can sort things and search for stuff and organize things into really efficient data structures so that you can run algorithms on them, some of which we'll talk about later in the term. And all they need for you to do to make your class fit into all of their happy stories is implement Comparable. So if you can produce a natural ordering for your class, suddenly there's all this code out there waiting in the Java library that is suddenly going to work. And so that's, again, one of the powers of interfaces, right? Like, and this is sort of similar to plugging two things together, right? I mean, if you built your cool microphone, the only thing you have to do to now be able to connect it to millions of machines is implement the USB protocol and provide a plug of the right size or whatever. So that's cool stuff. All right, any last minute questions or thoughts? Cat is still here. She's likes to snooze on the laptop, particularly when it's warm. It's been doing some number crunching this morning, so it's a little warmer than usual. So I think she's enjoying her snooze, at least until I start petting her, and she's not sure anymore. So I'll stop. Any other questions about today's topic? Otherwise, I think I will drop off just a little bit early today. Wish you guys all the best, and I will be back tomorrow. Good luck on today's homework.